Assalamualaikum and good day to everyone. I'm Elya Haniza binti Zamiruddin and I'm going to present my research paper entitled Oil Viscosity Effects on Lubricant Oil Film Behavior under Minimum Quantity Lubrication (MQL). To improve machinability in metal cutting, flat coolant or wet machining has been traditionally used in the industry because it provides the continuous flow of lubricant in low pressure to the workpiece and also to the cutting tool. However, by applying an excessive amount of lubricant oil will affect the manufacturing cost and also give a few negative impacts on the environment. For example, persistent exposure to the lubricant can cause severe health hazard to the workers, and also usage of flat coolant will cause the machine and floor to be wet afterwards, thus increasing the hazard of slipping. Therefore, MQL technology has been implemented as the great alternative to flat coolant. MQL is a lubricating method where it consists of mixture, air pressure and lubricant in the form of aerosol. And it is proven to be efficient in many perspectives, such as economic, occupational safety and health, environment and many more. And also, natural biodegradable oils have been widely used as an alternative to the traditional lubricant oil in MQL to meet the environmentally friendly machining environment. A few researchers have been studied about MQL, and mostly they've proven that better surface finishing and minimize the burr formation of the workpiece can be found in MQL operation. From the previous literature review, it shows that most of the experimental study of MPL technology will focus on the effects to the machining performance. The important issues that need to be highlighted is the study of the fundamental nature of lubricant oil, because to identify how does the lubricant oil behavior affect the lubricating process. However, the study is still limited, probably due to the complexity of experimental setup during the machining process is still ongoing, and the natural flow of the lubricant oil also cannot be disrupted during the machining operation. So, to counter this issue, the behavior of MPL lubricant oil during the milling process will be investigated using a non-intrusive method, and the effects of lubricant oil viscosity to the oil film thickness accumulated on the mill surface will be analyzed. There are two objectives for the study, which to measure the thickness profile of MQL lubricant oil under different oil viscosity. In the study, we presented by different types of oil. And the next is to analyze the MQL lubricant oil behavior on the workpiece under different oil viscosity. This table shows the experimental conditions and parameters for this experiment. As shown in the figure 1, this is the experimental setup for the milling process in this study. And figure 2 shows the image of MPL nozzle position during the machining operation, which shows the MPL nozzle generator was placed 45 degrees laterally to the feed direction and 3 mm away from the cutting tool. Calibration procedure was carried out before the milling process. This is to determine the relationship between emitted light intensity of test liquid and lubricant oil film thickness. As shown in the figure 3, this is the actual view of calibration procedure. The non-thickness board was placed between the optical flat and the workpiece, and test liquid was injected to the area, and the equation will be applied to calculate the value of lubricant oil thickness. This is the calibration result that we will be used to apply to calculate the value of lubricant oil film thickness in the milling operation. The calibration shows the relationship between emitted light intensity and lubricant oil film thickness of 4 types of oils used in this study. And it shows that As the lubricant oil film thickness is increasing, the emitted light intensity also will be increasing. The result shows that as the oil viscosity increases, the height of average lubricant oil film thickness along the milling point decreases, and also a similar downturn trend of average lubricant oil film thickness at all conditions of oil viscosity was shown, affected by the role play of MPL nozzle position, which the largely exposed at the beginning of the milling point and slowly decreasing towards the end of the milling point. To conclude from this study, the average of lubricant oil film thickness was significantly affected by the oil viscosity effects. And lastly, the MQL nozzle generator give effects to the dispersion of MQL lubricant oil onto the workpiece. That's all from me. Thank you.